Nature versus nurture. What makes us who we are? From our most superficial physical features to the most intimate aspects of our psychology, there are clearly many factors at work throughout our lives in shaping who we become. But ultimately, it comes down to our DNA and our life experiences. In this episode of the Thinking Tools podcast, I interviewed Dr. Robert Plomin on questions of nature versus nurture, centering on his 2018 book, Blueprint: How DNA Makes Us Who We Are. Robert Plomin is professor in behavioral genetics at the Institute of Psychiatry, Psychology, and Neuroscience at King's College London. He received his PhD from the University of Texas at Austin, followed by academic positions at the University of Colorado, where I used to work, and the Pennsylvania State University. In 1994, he moved to the UK. He has published more than 900 papers and is the author of the major textbook in the field, as well as a dozen other books. He has received Lifetime Research Achievement Awards from all the major societies in the behavioral sciences. Those are the Behavioural Genetics Association, the American Psychological Association, the Association of Psychological Science, the British Psychological Society, the Society for Research in Child Development, the International Society for Intelligence Research, as well as being made Fellow of the American Academy of Arts and Sciences, the British Academy, American Academy of Political and Social Science, and the Academy of Medical Sciences in the UK. In 2021, he received the Grawemeyer Award for Psychology. Professor Plomin writes that after 50 years of research, he has come to the view that inherited DNA differences are the major systematic force that makes us who we are as individuals. Our mental health and illness, our personality, and our cognitive abilities and disabilities. The environment is important, he says, but it works completely different from the way we thought it worked. The DNA revolution has made it possible to use DNA to predict our psychological problems and promise from birth. These advances in genetic research call for a radical rethink about what makes us who we are, with sweeping and no doubt controversial implications for the way we think about parenting, education, and the events that shape our lives. This is the theme of his book, Blueprint: How DNA Makes Us Who We Are. All right, so that is who I'll be talking to today. And just one last thing. As always, if you get anything out of this video, please like and subscribe to this channel and consider giving this podcast a 5-star rating. Now, let's get to my conversation with Dr. Robert Plomin. All right. Well, yeah, just first off, I just want to hear a little bit about your background and what led you to studying behavioral genetics in the first place.
Well, it's an interesting story, and there's a long version. I'll try to give you the shorter version. It's interesting, especially in light of the behavioral genetic results. So I describe in my book how I grew up in inner city Chicago, and no one in my family had it. Went to university, and there were no books in our house, literally no books. But I went to the public library, and I got books at an early age. And my sister, though, as I explain in the book, was slow to read and never liked school. I loved school. I did well at school. So why are kids in the same family so different? That's one of the major findings that we have. And here we are, growing up in the same family, the same parents. My parents didn't, push me and hold her back or anything. They were supportive of both of us. So that was kind of interesting. And then I went on to one of the other aspects that we find about genetics is also about the environment in a way. It's basically that I've come to conclude that most of the salient environmental influences are like chance. And as I look back on my history and how I got into behavioral genetics, it's like all these sliding door moments, where it could have tipping points, where it could have gone one way or the other way. And one of those, for example, there's a lot of these along the way, but one of them most pertinent to behavioral genetics is I grew up in Chicago, and I didn't know what graduate school was. And I had this wonderful advisor in psychology, Bob Brewer, who basically applied for me. He said, here are the applications, you got to fill this out and do that. And being an inner city boy, I just went to the place that offered the most money. And that happened to be the University of Texas at Austin. And I knew they had a good psychology program. But what I didn't know is they were one of the only places in the world that had a course series in behavioral genetics. And it was pure chance, but I don't know if US schools still do this at graduate school, but they had a core system of courses where everybody had to take 2 years of, courses across the board, perception and clinical and social. So I think that was great, but it was probably the only place in the world where every graduate student was required to take this general course in behavioral genetics. And that's because Gardner Lindsay was there, who's a former president of APA, and he's most well known for incest taboo as for his presidential APA address. But then in the Sputnik era of the late 60s, Texas hired him away from Harvard and said, you can have whatever you want. So he, at that point, was getting really interested in genetics. So he hired most of the behavioral geneticists in the world, all 6 of them, most of them doing animal work in the 60s. And so I came in 1970, and this was all just beginning. And so these guys team taught this course in behavioral genetics, and it absolutely floored me, I mean, because in my undergraduate career in genetics, the word genetics was never mentioned that I can recall. I look back at some of the textbooks, genetics is not mentioned. Schizophrenia, you look at the textbooks, it says it's caused by what your mother did to you in the first few years of life. Not a word about genetics. And so that sort of appealed to me. I mean, here's something brand new. It looked very powerful, mostly from animal studies. But, we don't hear about animal studies much, but they're very powerful. If you can select for something, as animal breeders have known for thousands of years, that's the proof of the pudding that it's genetic. So I was really impressed with these data. And I just knew right away, that's what I wanted to do. But the part of this that's interesting from a behavioral genetic point of view is there were 39 bright students in that class other than me, and not one of them was interested in behavioral genetics.
Wow.
So, why is it? I just knew right away, this is what I wanted to do. And yet it wasn't just the power of the course, because none of the other students wanted to do it. So it's interesting to look at these things from a genetic perspective, I think. And I think in addition to a lot of the aspects of environment being random, like these chance events, like me going to the University of Texas, there's also this concept we call genotype-environment correlation. I think the way the environment works is in this, not this passive way, which we were always taught in stimulus response theory. The environment's out there, it's what happens to you. But I don't think so. I think what happens is that we create and select and modify our environments correlated with our genetic propensities. So I think I used my environment to get where I got, and something in me, and I think it is often appetites as much as aptitudes, it just turned me on behavioral genetics. And I know if you talk to a lot of people and say, well, why are you doing what you're doing? And you often get stories like this. They can sort of make it sound like a good story if they want, but when it gets down to it, there's just sort of these tipping point moments, and then this funny business about, I don't know, I just sort of like doing it.
Yeah.
Partly because you're good at it, probably. Behavioral genetics at that time, it was very dangerous even to talk about genetics and psychology. And I think that appealed to me too. I'm kind of thick-skinned, and in some ways I like doing something that's a bit maverick. Whereas there's other people with more sensitive personalities or whatever who, might have been intimidated by that. But it actually kind of turned me on, that I thought, this is really powerful stuff. Everybody's ignoring it, and I'm going to stick it to you. I'm going to do this research and show you.
Yeah.
This, find out it, but in the end, showing people that genetics is, I think, the single most important systematic influence in psychological development. So that was actually getting into the longer version of the story, but it does bring up several interesting points about behavioral genetics.
It does, and it touches on some of the core themes in your book that I want to get to in a second. But just as an aside, it's interesting because the other behavioral geneticist who I've interviewed, John Hewitt, who is the editor of the journal Behavioral Genetics, and his story, to your point, was very similar in just what drove him to get into it. I mean, it was just an emerging field, and he just found it fascinating. So very, very cool to hear that parallel. So getting to your book, you covered some of the big themes in your book, like the nature of nurture and some others. And I wanted to know, what is your thesis in Blueprint, if you could try to boil it down? I know there's a lot of ideas in there, but if you had, just down to one idea or a couple.
Well, I think one big idea is not just from this book. I mean, the book is the culmination of my 50 years of research in the field. So it's not meant to be a completely academic, scholarly review or meta-analysis of research in the field. It's meant to be my perspective on what's happening over 50 years. Because I was there sort of at the beginning and during the rough ride in the 1970s, where psychologists were very upset at the notion of genetics. And then to see psychology coming around to it, to the view of a more balanced view of nature and nurture. But anyway, one big set of findings has to do with the environment. I think we've learned as much about the environment from genetic research as we have about genetics. And that's because environmentalism dominated psychology for so long. The view that you are what you learn, and schizophrenia, it's caused by what your mother did to you in the first few years of life. By ignoring genetics, I think we, after a century of research on the environment, didn't really know very much about the environment, because our environmental studies were confounded by genetics because they didn't take genetics into account. And when we do, one of the biggest findings is that the environment works quite differently from the way we thought it worked. From Freud onwards, we thought the environment was nurture, systematic effects primarily of the family environment. And it makes perfectly reasonable sense. Children who grow up to be schizophrenic have parents who are more likely to be schizophrenic. So it's easy to say, well, sure, that's nurture. But you say, but what about the fact that they're 50% related genetically? And when you take that into account, genetics accounts for the similarity in families, what runs in families. The environment's important because what we found is, on average, inherited DNA differences account for about 50% of the differences for all psychological traits, maybe less, 40% for personality, more for cognitive abilities, say 60%, but a huge amount of variance is due to these inherited DNA differences. And I should emphasize, we're talking here about differences between people. Why are some people schizophrenic, others not? Why are some kids reading disabled and others not? We're talking about differences. And what this type of genetics does, twin studies and adoption studies that we'll go into, is it asks the extent to which the differences you observe, like reading disabled or not, to what extent can those be explained by DNA differences between people? So we're talking about differences here. And when you take genetics into account, you find that familial resemblance is due to genetics, yet heritability, that is the extent of genetic influence, is about 50%. So that means 50% of the differences, the variance, is not explained by genetics. But it's not due to shared family environment. Whatever it is, it's making two kids growing up in the same family as different from each other as our kids raised in different families. And this is mind-boggling. But you only see it when you take genetics into account. So I think that's probably the single biggest finding. It's very hard for people to get their head around it, but to help people along, you can say, well, any aspect of the environment could be thought of as creating differences between kids. For example, we think of parenting. Well, developmental psychologists only studied one kid in a family because they just assume that the environment is monolithic. That is, here's your parent and kids in that family, that's the environment they experience. But you can say, to what extent do parents differentiate in their behavior to the kids, for example? And do two kids in a family, say, have different peers, accidents, illness? So there's lots of ways of looking at this. But after 30 years, we haven't really come up with much of these systematic sort of factors that could explain environmentally why kids in a family are different. So I've come to conclude that the salient environmental influences are idiosyncratic and stochastic, and in a word, really chance.
Yeah.
And so they're not unimportant, but they're just not these systematic factors that we thought they are. And
Right.
that's because of the other finding about the environment from genetics, and that's the nature of nurture. What looks like systematic effects of the environment are actually genetic effects in disguise. If you think of correlations between, say, parenting and children's outcomes, it's almost hard to resist interpreting those correlations causally, even though we all know correlations do not imply causation. But parents who read a lot to kids have kids who read better when they go to school. It just seems obvious, well, it's because the parents read to them. But is it? Because they 50% similar genetically could mean, and it does mean, that parents who like to read have kids who like to read. Parents who like to read and good at reading and read for pleasure have kids who learn to read better, faster at school. So a lot of what looks like systematic effects of the environment are actually mediated genetically to a substantial extent. So,
Yeah.
so this idea of chance is really interesting to me. And the idea that kids are using they're actively selecting and modifying, creating environments correlated with their genetic propensities. It's not the environment out there affecting them. It's them actively interacting with their environment in a way that fosters their genetic propensities. So it's an entirely different way of thinking about the environment. So,
Yeah. Yeah.
I think these two findings about the environment are probably in my view, the single biggest finding, other than showing that everything's heritable.
Yeah, that's fascinating. And to dive in a little bit on the point of um, the nature of nurture, the sort of inherited aspects of the environment. A really interesting comparison, really interesting thing that you say in the book is if you look at where people live and the kind of weather patterns of the place that they live, you would say, from the outset, well, that's an entirely environmental measure, that has nothing to do with genetics. But as you argue and you explain, our genetic propensities for, whether we like to be in a warmer climate or we prefer the sun, that will sort of influence us to move to places or to live in those kinds of places, or even just to perceive to remember our environment as being sunnier and warmer than it is. And maybe you can explain that a little bit more.
No, that was very well said. The idea there was to say what we're finding is that not only are all behavioral traits heritable, but most of the environmental measures that we use in psychology show genetic influence. And like one crazy example I did just to piss people off in a way was books in the home. Or one of our earliest studies was television viewing, which was viewed in thousands of studies. How much TV, what kind of TV do kids watch? That's viewed as kind of like the ultimate environmental measure. But is it? For sort of the reasons you said. When kids are very young, maybe the parents control the television. Back in those days they did, probably less so now. But to a large extent, kids watch what they like to watch. And kids who are more active and want to do physical things, they're not just sitting there like vegetables in front of the television. So they're using this environmental factor in a way that you could say fosters their propensities, but it kind of fits their appetites and their aptitudes, the type of TV they watch. But so then I went to the extreme of weather, and we haven't done a study on this, but just to say what could not possibly show genetic influence in the environment. And you'd say, well, the weather, like Samuel Clemens, Mark Twain said, everybody talks about the weather, nobody does anything about it. So the weather seems to be something like you can't do anything about it. But as you said, you certainly can. If you think about it, you can say, if you have seasonal affective disorder, you probably don't want to live in London. It's cloudy and gloomy a fair amount of time. But then the other point you make, I think, is even a bigger point, and that is, it's our experience that counts. And I say in the book, I'm such a disgustingly optimistic person, in the sense that it can be irritating to some extent. But, you know, I can look back on last summer's weather and say, oh, God, wasn't it great? You know, I remember the swimming and the sailing. And people say, are you kidding me? It was the worst summer on record. It was cold and miserable, but it wasn't for me because my experience is what counts. And people say, oh, it's just perception. But I think perception is what it's all about.
Yeah. Yeah, it's a really, really cool idea. Now to backtrack a little bit, you talked a bit about parents and parenting, and I want to dive a little bit more into that. So the kind of slogan that you use a few times in the book is parents matter, but they don't make a difference. So can you explain what that means? And how can they matter but not make a difference in childhood psychological development?
Yeah. Well, that was meant to rattle cages a little bit, you know, that phrase. It's probably the most quoted 4 pages in this book about parenting. And so the idea is that parents obviously matter in the sense that babies need a caregiver. And more, it's not just physical care, they need psychological care. So parents really matter. But when I say they don't make a difference, what I'm talking about is individual differences in children's outcomes. I mean, does it matter how controlling the parents are or not? And the other major dimension is how affectionate and supportive are they or not? And we always assume from an environmentalistic perspective that that's what counts in kids' development. But based on the research I told you, they don't make a difference. These environmental influences are important, but they're not shared by 2 kids in a family. And I think it's such an important message for parents to note, because I was going to write a follow-up book based on that. And I tried to do it for a while, but parenting books are just not my thing. You know, you have to write about, in a folksy sort of way, you know, and I decided that wasn't what I wanted to do. And fortunately, someone else has just published a book along those lines, Danielle Dick. You might
Oh,
want to think about interviewing her.
yeah.
It's the first parenting book. There's literally thousands of parenting books on the market, and none of them talk about genetics. And I think genetics is the most important thing parents need to know, because what it tells you as a parent, and certainly some of the people who are listening to this are young parents or at risk for having kids, they need to know that genetics is very important. You don't have as much control as you think about kids' development, because genetics is the single most important systematic factor. But the other reason why you don't have as much control as you think is that most of the environmental influences are non-shared. They're not systematic effects of the family environment. And I know that's hard for people to accept, but I think the data are very strong on that point. And then people say, oh, well, then what do? You just throw your hands up and say, well, can't do anything about it. But it's not true. It's a profound message that parents matter, but they don't make a difference. As a parent, it bugs me that the media and parenting books, they like to make parents anxious, and they say, well, you've got to read this because, or I read in the newspaper every week about a correlation between parenting and children's outcomes. And, it's sort of designed to prey on the anxieties of parents, saying, oh, if you don't do this just exactly the right way, your kid's going to be screwed up. And I think the main message from genetics is relax. You don't make much of a difference anyway. So why not enjoy the relationship? And I think a lot of the concerns about parenting are counterproductive to a good relationship with your kid. And part of that enjoyment is standing back and watching them become who they are genetically. Instead of thinking, if there are any people out there who still think the kid's a blob of clay that you mold to be what you want it to be, boy, you really got to read the book, because that's guaranteed to make you unhappy, and probably to make your kid unhappy too. It's like if you marry someone and you think, well, pretty good, but I'm going to shape her up and make her into a decent wife. It's a disaster. You do things for them because you love them and you want them to be happy. And I think we need the same attitude towards our kids. We don't do things for them to make them be the person we want them to be. We do things for them because we love them. We tell them, we say, if you do that, you're going to be in a world of pain. People aren't going to like you, so don't do that. Make it easy on yourself. But you don't do it because you're trying to create a product, It's such an important distinction. And the cool thing is parents matter, but they don't make a difference. So relax.
Yeah, and maybe take some of the blame off of parents who feel that they may have been responsible for negative outcomes or something like that. But
yeah, exactly right. That is such an important point. I get a letter at least once a month from someone who says, I've tried to do the right thing. I've been as good a parent as I can be. And then say adolescence, the kids goes off into drugs, hangs out with a bad crowd or whatever. Or the worst is, in a way, schizophrenia, which affects 1% of the population. But you don't find out until your late teens or early 20s. So here you've had this kid, you've had, the usual relationships, ups and downs with kids, but, everything seemed fine. And suddenly they become psychotic. And then 20 years, 30 years ago, you would have been told, it's because of what you did to the kid in the first few years of life. I mean, how wicked is that? And that's why parents of mentally ill children are big supporters of genetics research. And some people say, yeah, well, they would just get them off the hook. And that irritates me a lot because there's no hook for them to be on. It's not their fault. So when things go bad, it's very good to know this message about parents matter, but they don't make a difference. And it's more difficult to accept it for the good stuff. We're very happy to take credit for doing well at school and all of that. But all kids are going to have their downs as well as their ups. So it's good to know that you're not responsible for that.
Yeah, that makes a lot of sense. Now, and maybe even more controversial claim, I don't know if it's more or less controversial, but you go on to say that schools matter, but they don't make a difference. And even that life experiences matter, but they don't make a difference. So maybe we can talk a little bit about schools and how this situation is analogous to parents. And maybe we can talk a little bit about what the evidence is for these claims.
Yeah, well, good. Well, I wonder how many people reading the book understand, why schools matter, but they don't make a difference. I do try my best to explain it, but it's the same sort of argument. Kids, I don't know if they need schools. Many kids are home reared these days, but they certainly need to learn the basics of culture and skills like reading and to some extent math and writing. So the schools matter. They've got to be good enough to provide those sorts of skills. But the question of differences, do they make a difference? That is, going to a better school or a less good school, within the range of schools we have, does that make a difference? I should use this as a way of saying, we're only talking about the normal range here of parenting and the normal range of schools. You lock a kid in a closet and they are not going to develop very well cognitively. Right. But we're not, and so similarly, there are many severe mutations that will cause terrible cognitive impairments, for example. But we're talking about the 95% of kids in this normal range of genetics and environment. And with schools, it may be that schools, and we're also talking about this at a specific time. And in our era, maybe schools are good enough. Maybe in England, we've weeded out a lot of the bad schools. We have these school exam, we call them Ofsted. They're where independent evaluators go into schools for 2 days and they get all the information about the schools. They observe teachers, they talk to the janitors, they talk to the kids, they talk to parents, observe on the playground. They're really good assessments of schools. And they fail schools and they have like a year to pull up their socks or someone else takes them over, so that's been going on for 20 years. And I think we've weeded out a lot of the worst schools. But as a result of those evaluations, we have these league tables in England. in the UK. And they're based on these Ofsted ratings and how well kids do on the national exams. You know, kids in England are more tested than kids anywhere, I think.
Mm.
And so we have these national exams that you take at the end of basically high school at age 16. And so that gets into the league tables. So there's schools that are considered better or worse. And parents make themselves very unhappy by trying to get their kids into the best high schools, for example. And so in England, unlike the States, you are in the States, aren't you?
Yes,
Yeah.
Colorado.
Oh, right. Yeah. Are you still in Boulder?
No, I'm in Longmont, but yes, grew up in Boulder.
Yeah. Well, in the UK, we have a lot more private schools than you do in the US. And these are fee paying, basically. And some of them are incredibly expensive. And some parents will, before the kid's born, get their kids in line to go to the right preschool, to go to the right elementary school, to go to the right high school, so that they can get into Oxford or Cambridge. And I mean, we're talking hundreds of thousands of pounds to do this, you know? And the stress that comes from that, because kids differ, you know, two kids in the same family, like me and my sister, I'm sure the differences are genetic. You know, I haven't tested her for DNA yet, which we could do, but my prediction is, you know, she's just not as academically oriented. She's done very well in life, better. She's saved a lot of lives. She's a head of a lab, a blood lab at a hospital, you know, and she's just very good at that sort of fine work. I wouldn't want that responsibility. I mean, you know, you do something wrong and you can kill somebody, you know, so it's a good example of how kids differ. So anyway, parents spend a lot of angst and money getting their kids to the better schools. Well, those schools differ, but those are mean differences between schools. You know, some of them have kids who get higher national exam scores than others. So it's basically a correlation. The better schools, the so-called better schools, they have kids who do better on average on these exams. But it's a correlation, but everyone just assumes that's environmental.
Right, so a selection effect. The kids who are more apt to doing that kind of academic work will be the ones who are in those schools. Is that?
Exactly right. So that's the counter argument, that it's a self-fulfilling prophecy. These schools select the very best kids. In fact, the kids who don't do so well get booted out because they've got to keep their marks up, you know? So it's a self-fulfilling prophecy. And we've actually shown that when you test for what the schools select on, that is like the prior achievement and the cognitive ability of those kids, you correct for that, then there's no difference in how well the kids do on these national exams, meaning there's no added value. Now, when I tell parents that have spent £300,000 to get their kids in the right school, they're not well pleased by it, but they will admit in the end that, well, they're not just concerned about school achievement. They want them to be with the right sort of people. They want them to have contacts and stuff like that. You know, maybe they think they're maybe better. They have better resources. But on the other hand, there's more self-harming in these high pressure schools. You know, like my grandson's doing very well in a state school, and they wanted to put him in one of these pressure cooker selective schools, and he probably could have gotten in. I wasn't willing to pay all the money for it because I, you know, really believe we should be putting our energies into comprehensive, good education for everybody. And if people like me take the kids out of those government schools and put them into these fee-paying schools, you know, we're perpetuating the system. But my son's argument is, yeah, but this is your grandson here. You know, it's a difficult decision for people to make. But I can say, well, empirically, it doesn't make a difference. And I can see downsides as well as upsides. So the data that I like the best on this is that people are so into these league tables. No one ever said, well, you got all these Ofsted exams. Each one costs £10,000. They visit each school every 3 years or so, a huge amount of data on the quality of these schools. Okay, how much variance, that is, how much of the differences between kids on these leaving exams called GCSE exams, how much of the variance is explained by that? And the answer is 4%. Wow. And then if you correct for socioeconomic status, because these kids are not just randomly assigned to schools, the kids from wealthier, more educated families go to schools that are better on average. If you correct for that, you're down to 1%. And yet, GCSE scores are 60% heritable. That means 60% of the variance is due to genetic differences between kids. That's from twin studies, comparing
Wow.
identical and non-identical twins. So you got 60% of the variance due to genetics, 1% due to the best measure we have of school quality. So that's what I mean when I say schools matter, but they don't make a difference. And I wish, like I said about parenting, I wish it was more oriented towards not the stress of these high stress exams that determine whether you're going to get into this better school or not, or get into Oxbridge. That's what they call Oxford and Cambridge, Oxbridge. And really foster enjoyment more of the learning process, because this isn't just some airy-fairy idea. It's said that most of the kids today are going to end up in jobs that don't exist now. They've got to be adaptable and like to learn. They're not going to, it's not like when I grew up where, like Bruce Springsteen said, at 16, you get married and you get a job and that's all she wrote, because you get a job for life, you're in that factory for the rest of your life or whatever. That's just not happening anymore. So it's important that kids learn to learn rather than get stuffed with these facts. And here we have a national curriculum where there's certain facts and things they have to know. And it can be counterproductive to enjoying learning. I have a granddaughter who's, she's now in a PhD program actually, but she had a lot of trouble in adolescence, but she loved biology. And she went and, let's see, I'm trying to avoid the long story here. The short story is she went to her biology teacher and she asked questions about something that he had not gone into, but tweaked her interest in biology. And he actually said, "Oh, you don't have to worry about that. That won't be on the exam."
Wow.
I mean, bloody hell. Here's a girl who was not academically oriented, expressing an interest in academics. And he says, just kind of the whole mindset is, it's about doing well on exams. So
Wow.
fortunately, she surmounted that, and continued to become interested in biology, and then, was going to go into medical school and is now doing a PhD at the Crick in molecular biology. So I think it's really a success story in the end, but it's sort of despite the system,
Wow. I guess her genes got their way, it sounds like.
Well, I do
Perhaps.
think, if you can, it's more a matter of staying out of their way. And I think I tell parents, but I think it's also true for teachers. You want to think of yourself like a resource manager. You want to help the kid find out what they like to do and what they're good at. And to do that, you got to expose them to a number of things, and you got to pay attention, because sometimes kids don't really know. They're more influenced by their peers or whatever. So, and again, you do that not because you want them to be what you want them to be. It's actually the reverse. You want them to be what they want to be. And if that's an artist or someone who just wants a job because they like a lot of other things in life, they just want enough money to get by, they're not interested in making a fortune. So it's such an important message, I think, for parents and for educators, that these things they're important, they matter. We want it to be nice. We want parenting to be nice. It's the longest period of your life, with somebody, your kids. You have them for the rest of your life. You want it to be nice, but it'll be nicer if you think about it as a relationship and you're not doing things, you do things for them because you love them, not because you want them to be what you want them to be. So I decided in the end, some people advise me against those headings called parents matter, but they don't make a difference. Schools matter, but they don't make a difference. But I decided to keep it in just to make people get the message. Although I don't know how many people actually got that message. Do you know what I mean from reading the book?
I think it does come through clearly what you're trying to say. I think a certain type of person can just disregard what the intended message is and just read into it whatever they kind of whatever kind of villain they want to make you out to be. But no, I think your point is clear in the book. And, I think everything you said, just it really encapsulates it. Like, you're not saying that parents or schools that we should get rid of them in any sense, but that they're more facilitatory. They kind of facilitate the child's development, but they don't shape him like a ball of clay.
Yeah.
So I think I'd like to transition into some topics on mental health and psychopathology, because you spend some considerable time in the book on this idea of the abnormal is normal. And I think that was one of the most profound ideas that I read in the book, that just really floored me when I was listening to it. And so if you don't mind, I want to quote you from chapter 5 and then have you explain a little bit of what you mean. So I'm going to go ahead and do that.
Great. Andrew, I'm really glad you picked that up, because I don't hammer that as hard as I do some of the other findings, but I agree with you. That's going to have a huge impact. I mean, it's not my finding. It's sort of, I've contributed to it, but it puts together a lot of work. And the molecular genetics, which we'll get onto, the DNA revolution, that really is the nail in the coffin of these diagnostic categorical approaches to mental illness.
Oh, yes. Yeah, it's really fascinating. I mean, so you say, for example, you say, quote, genetic research shows that the medical model is all wrong when it comes to psychological problems. What we call disorders are merely the extremes of the same genes that work throughout the normal distribution. So can you explain that a little more? And then why are there no genes for individual psychological disorders? Maybe that will kind of help frame your explanation.
Okay, well, we could take that point about DNA and what it tells us about this, and just maybe that's easier for people to understand in some ways. Most of the studies trying to find genes, and this is the DNA revolution in the last 10, 15 years, no longer are we saying is something heritable, because everything's heritable. The next step is to try and find some of those genes. And for 10 years in the 90s and going into the late 2000s, weren't very successful. And there was a new technique that came along called SNP chips as a technology and genome-wide association studies, which we could go into, but they're a completely different way of trying to find genes. It's not finding the gene. And what these studies have shown, there's many, many genes involved. But
yeah,
anyway,
feel free to go into that if you'd like to, into the science of GWAS.
Well, let me first, before we get diverted from this point, let me tie this into what you were asking about. And that is, these studies are often case control studies where you have diagnosed, say, schizophrenics or people with major depressive disorder, and controls, people who don't have it. And they find genes that discriminate between the two groups. That is, people in the control group have a higher frequency of one allele than the people in the control group. And this is true for all of medicine. It isn't just psychiatry. And so people assume, well, those are the genes for obesity or schizophrenia, alcoholism. But then when you say, well, let's look at that gene in the population, is it distributed dichotomously? The people with schizophrenia have that. And it's not, all these genes are distributed quantitatively. The first one that came up that way, using these new methods called genome-wide association, was a gene supposedly for obesity. And it showed a big difference, well, not a big difference, but a difference in frequency between the obese group and the controls. But then when you study, you say, well, okay, but how does it relate to the normal distribution of body mass index, of weight? And it works just linearly across the distribution. So, for example, if you and your sibling have the genes that this one gene, if you have, there's so much to go into here, but if there's the DNA code has a 4-letter alphabet, A, C, T's, and G's. And if you had 2 A's rather than 2 C's for this particular gene, you're 6 pounds heavier on average in a large group of people. So it's a fairly big effect. But that's just as true if you and your sibling are skinny. If you have 2 alleles, you'll be heavier than your sibling. It works completely quantitatively rather than qualitatively. And
So,
that's true for all the genes that have been found for all disorders. They're
yeah,
not dichotomous, they're all continuous.
right, right. So to give people kind of something to hold on to, we have, there's what, like 20,000 genes or coding regions in the human genome. There are about 20,000 genes, right? And so you've got this huge amount of variety, and each of us may have slightly different versions of each gene, but each of those versions is normally distributed throughout the population. And stop me or correct me where I'm going wrong. And individual versions of those genes will be associated with, if we're talking about obesity. So if we have, gene version A and gene version B, and version B is associated with, a 2-pound increase in body weight on average. It's not that people who are obese, it's not that only people who are obese have that version B. It's that version B might be distributed throughout the population, and people who are heavier on average are more likely to carry a copy of version B. Is that a reasonable?
Yeah, there's a bit more to it. And that is, if that gene were solely responsible for obesity, like if you had AA, you are obese. And if you don't have AA, you're not obese, then it would be dichotomous. And there are thousands, we call those single gene disorders. So Huntington's disease, which Woody Guthrie died from, is on chromosome 4, and it's a single gene characteristic. It's necessary and sufficient for developing Huntington's disease, which is a degenerative neurological disease later in life. So it's necessary and sufficient in that, necessary in the sense that you don't get Huntington's unless you have that gene, and it's sufficient. If you get that gene, that form of the gene, you will die from Huntington's unless something kills you first. There's no environmental influence on that. So that's the way people learn about genetics from Mendel. Mendel was studying pea plant characteristics like that, single genes necessary and sufficient for the development of yellow wrinkle versus smooth seeds, for example. So the problem is that when we deal with complex traits or common disorders, the vast majority of the burden of medical burden in society is not these single gene things. Even though there's thousands of them, they're very rare. 1 in 10,000 is common. They're often 1 in 500,000 or 1 in a million. They're very rare. So in the population, these common disorders aren't caused by one gene. Like this obesity thing, the example I gave you, that particular DNA variant accounts for 1% of the variants. There are many, many genes that account for the heritability, maybe thousands of very small effects. And so that's what really turns the deterministic, hardwired single gene into a probabilistic propensity, because there are many genes involved, and they are normally distributed. Each gene is dichotomous in the sense that you can either have 0, 1, or 2 alleles version, of that, because you get 2 chromosomes. So you can get 0, 0, you can get 0, 1, 1, 0, or 1, 1, of the 2 forms of these gene. So when it's going from what we call a single gene disorder to polygenic, where there are many genes involved, that makes it normally distributed. And all the common disorders, all the traits we study in psychology are normally distributed. And so that's why there's no, you can study the extremes. I mean, they are quantitative distributions. Like with reading, for example, it's perfectly reasonable to study kids who have problems, but there's nothing to be gained by pretending that it's an etiologically distinct disorder, which is what the medical model wants to do, because that medical model is based on simple causes. You know, cholera is caused by bacteria in the water, for example. So you want to find the cause, and then you fix the cause, and you've cured the disorder. That's great if you've got a simple single factor. That case is environmental in a way, but also a single gene disorder. The problem is that's not what we've got here. And so I say there's nothing to be gained. In fact, I would say the medical model has held us back in psychiatry and psychology because, you know, it's all based on this idea that the first thing you do is diagnose it. You got to say who's got cholera and who doesn't have cholera, you know, and it goes to an extreme in psychology because it's not enough to say here are some kids with reading problems. You give it a Latin or Greek name, it's dyslexia, and then the parent can say, "Oh, my kid's got dyslexia." Now, it's not to be dismissive of the problem. The problems are important, but I don't think we gain anything, and I actually think we lose quite a bit by pretending these are ideologically distinct. Because if there are no ideologically distinct disorders, if it's all quantitative, a matter of more or less rather than either or, that means there are no cures in the sense that you don't cure somebody, you alleviate the problems quantitatively.
Right.
And so it's not to say there aren't problems, there certainly are, but we'd be much better off trying to look at them quantitatively. And I don't know if you know DSM-5, which is the latest
Yes.
version of the diagnostic manual. They tried to have a shadowed version of diagnoses using quantitative approaches,
Oh,
but vested interest put the kibosh on it in a way. I mean,
wow.
insurance companies don't like it. They want to know, do you have it or don't you have it? You know, this
Right.
disorder.
Right.
And, you know, but you could do that quantitatively, just not pretending that you've diagnosed this categorically different disorder. And that's what they were trying to do. And it'll eventually happen because the diagnosis, you know, I'm at the Institute of Psychiatry. And when I first came here 25 years ago, I was started to very quietly say, you know, you spend all your time diagnosing these people. I mean, do you really believe that? Does someone really, you know, depression? I mean,
Right.
alcoholism? These are
Right.
quantitative things, and they vary according to functionality too. I mean, there's some high functioning schizophrenics and alcoholics who can, you know, get by in life pretty well. So I think there's a lot to be gained by tearing up the diagnostic manuals.
Right. Right. Yeah. And I mean, just to give people kind of the way that I sometimes think about this is if you look at the DSM-5 diagnosis for depression, it's like a 20 item checklist or something like that, where you have to have had these symptoms over a course of 2 weeks, every day or nearly every day or something like that. And it's sort of just this arbitrary number. You have to have this, you know, 10 of these symptoms, or I don't know what the exact numbers are, but for this long, and then you have depression, you have major depression if you have that. But if you don't have one of these, well, then you don't have major depression. But as you're saying, you know, these are quantitative, and maybe we can talk a little bit. I don't know actually, how much time do you have now?
Well, we've been at it almost an hour.
Almost an hour.
We had said we'd go another half hour, but I can go a
Right.
bit longer if you want.
I think half an
What's your
hour
time
should
like?
be just fine. Yeah, I'm open, but we can
Okay, well,
jump
let's
in,
see how
see how
it
it
goes.
goes.
I've enjoyed the conversation so far.
Great. Yeah, same here.
I'm
Um,
amazed I'm so talkative at the end of you know, here in England, it's the end of the day. It's 5 o'clock, and I've been talking all day. So I thought, oh no, I'm not going to be able to open my mouth. But somehow you're drawing me out.
Good. I'm glad to hear that. Yeah, I have the advantage. It's like 9, it's almost 10 a.m. here. But all right, so maybe we can talk about how they're quantitative in the sense of polygenic scores, and maybe we can get into that. What is a polygenic score? And you can start from wherever you'd like, the most basic, however you'd like to go with that.
Okay. Well, in the 90s, when I and other people were trying to find genes responsible for heritability, all we could do is look for what we called candidate genes. You had to do each DNA variant, I should say there's 3 billion base pairs of DNA in the spiral staircase of DNA. And the most common type of variant is a single step in that spiral staircase. So say most people have C on their chromosomes, but there's a mutation maybe that happened thousands of years ago where there's a T and it gradually flows through the population. So that's what we call a single nucleotide polymorphism SNP. Well, when we first started doing this work, these weren't even discovered till the late 1980s. And then as the human genome sequence came out in 2003 or so, people said, well, there is no human genome. There's a lot of differences. There's human genomes. And then they started, because they had the sequence, you were able to then do it for more and more people. And you find out, oh, look, there's these millions of DNA differences. And so that's what we're focusing on. It's only about much less than 1% of those 3 billion base pairs that differ between people. The 99 point, maybe 9 or 0.8% of the DNA steps in the spiral staircase are the same for all of us. That's what makes us human. But we're interested in that less than 1% of the differences, and to ask, does that make us different genetically? Does that account for heritability? And even if it's only 0.1% of difference, 99.9% are the same, 0.1% of 3 billion is still 3 million. So there's still a lot of these DNA differences. So that's what we're trying to study. But back then, before the mid 2000s, before 2005 or so, we had to genotype these one at a time. And they were very expensive. So as a result, what people did is they said, well, you're studying hyperactivity, dopamine, we know methylphenidate is used as a treatment for hyperactivity, and that works on dopamine receptors. So let's look at DNA differences in the dopamine receptor. So that's called a candidate gene approach. And that there were 10 years of that, thousands of studies. And it's genetics contribution to the replication crisis. I'm sure your listeners have heard of the replication crisis. They did everything wrong. You start out with this hypothesis, you don't specify particularly, and you tend to, they call it chasing p-values. You want to get it to the point, oh, it's significant, 0.05, so did absolutely everything wrong, and actually looked at a number of different genes. Oh, this is significant. These are all the no-nos in terms of the replication crisis. So that was a depressing time, because people would say, oh, found a gene for this, we found a gene for that. But we know now why those didn't work, and that is the effects. There's so many genes responsible for heritability. Each effect is so small. Those early studies, which were hampered by the expense of doing genotyping, couldn't do huge samples. And why would they? Because everyone assumed heritability was due to a handful of genes. No one thought what we know now, it's due to thousands of DNA differences. And that means the effects are going to be incredibly small. And as psychologists, we know what that means is you need monster sample sizes to be able to detect those small effects. But how are you going to do that? If each DNA difference is expensive, it takes a long time. So the DNA revolution started with a technological advance called a SNP chip. I won't go into it in detail, but there's a chip, a DNA array, the size of a postage stamp, that can genotype hundreds of thousands, typically say 600,000 SNPs, quickly, cheaply, and completely accurately. And so that made it possible not just to study candidate genes, a handful of them, to say, let's go the other way, the opposite of a candidate approach. Let's take an atheoretical approach, an agnostic approach, study all the DNA differences in the genome and just say, well, which ones are related? Now, that's a huge multiple testing problem. And as a result, you need very large samples to be able to do this. But people have done it. There's been a lot of collaboration over the years. And right now, the best predictor in the behavioral sciences is for a really crummy variable, educational attainment. How many years of school did you go to? The reason that's the most successful one is because every genome-wide association study, whether it's for heart disease or cancer or anything, any cognitive ability, they always ask demographic questions, one of which is, how many years of school did you have? So we were able to take that measure in huge samples. So the one study was over 1 million people, and it's now moving up to 3 million people. And as you go up, the first studies, people had 1,000 subjects and they didn't find anything. But that's because the effects are very small, much smaller than anyone ever anticipated. Okay, so now we have thousands of DNA differences that are statistically significantly associated, but they're very small. And so what do you do with that? Well, if you're a molecular biologist and you want to go from the bottom up, from genes to brain to behavior, that's going to be really tough because the biggest effects account for about 0.05% of the variance. Most of these significant effects, they probably average out at less than 0.01% of the variance. That's
Wow.
0.001. This isn't p-values. These are the effect sizes. When I said heritability accounts for 60% of the variance, that's 60.00. Here we're talking about explaining 0.001, no, 0.0001 of the variance. So you can see it'll take thousands of DNA variants to be able to get up to that 60%. But we are now, with that genome-wide association study of 1.1 million, we can explain 15%, well, you can explain 12% of the differences between people in how many years of schooling they had. That was the target variable. But that's a crummy variable. It's not at all normally distributed. It's almost bimodal. There's people who stop at high school, people who go on to university. But what we did is we said, well, that is a crummy variable, but if it's getting at things related to achievement at school, how about how much variance does it explain in tested school achievement? So how much variance does it explain in these GCSE scores, even though that wasn't what it was designed to predict? And we showed a couple of years ago that if you put these, I skipped a step here, you got to put, how do you work with these tiny effects? Well, psychologists know you just aggregate them. It's like items on a test. You weight them by their effect size and you add them up. And that's what a polygenic score is. And we showed that the polygenic score for this genome-wide association study of educational attainment, years of schooling, explains 15% of the variance in GCSE scores. That's 15.0.
Wow.
And you remember what I said about school equality, explaining 1% of the variance?
Yes.
1%, 15% on the first go. And we can go up to 60% because it's 60% heritable. So we're at 15% now. But I think with the next GWAS, genome-wide association study about to come out with 3-point-something million people, I bet we'll get that up to 20% at least.
Wow.
So that's polygenic scores, and that's why it's so exciting. But getting back to your point about disorders and dimensions, these polygenic scores for everything are perfectly normally distributed. And that has to be true from a simple statistical probability point of view. This is called the central limit theorem of probability. It's the old idea of flipping coins. You're really flipping alleles here. You either get a heads or a tail, but you get two of those. So you can, on one throw at that snip, you can have 2 heads, 2 tails, a head and a tail and a head. So it's exactly like that. But with flipping coins, how many heads do you get? Well, first time, you might get like Waiting for Godot, sort of. You get tails, 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 but then you get heads, heads, tails, heads. If you do it long enough, or you have enough genes, like thousands of genes, you get a perfectly normal distribution from people who have most of the positive alleles, the forms of the gene, to those who have low polygenic scores. That is, they don't have many of the risk alleles, for example. So it's perfectly normally distributed. And there are none of these associations that are for a disorder. Any any association that's found will work throughout the distribution in a linear way. So this is really revolutionary. But this is the, as I said, the nail in the coffin. But for much other data in genetics has been pointing to this as well. If you just question this dichotomous thing, if all you've got is zeros and ones, that is cases and controls, you know, you can't do anything with that, because, you know. But if you say, well, wait, now, if you really think there's a liability of risk underlying this, well, let's try to measure these things quantitatively. Or in genetics, we can say, what's the heritability of these disorders? To what extent do the genes that affect the disorder, are they related to genetic variation throughout the distribution? And it's always the case that, actually, this work was first done by John DeFries. You interviewed John Hewitt, and John DeFries was the director of IBG, the Institute for Behavioral Genetics, before John Hewitt, and he developed this method. It's called DF extremes analysis, where you can look at the extent to which genetic effects at the extremes or for a disorder are the same genetic effects that work throughout the distribution. I won't try to explain that now, because it's easier to see at the molecular level. If you find a gene for a disorder from a case control study, it's going to work throughout the distribution if you measure it. If all you have is a 0 and 1, you know, you can't go any further with it. So my argument with people is, if you do diagnosis in cases and controls, all you've got are your zeros and ones. If you take a quantitative approach, you can also have the zeros and ones. You can say these people are ones, that is, they meet diagnostic criteria for a case. So it just seems to me so obvious, it's got to be better to be able to look at it both ways.
Right. Right. And one of the things you do in the book is you look at your own polygenic scores for multiple different things like schizophrenia and educational achievement, I believe. And you say, you know, kind of relating it to your own life story and saying, well, you know, does my polygenic score for schizophrenia or for educational achievement or attainment, sorry, does that square with my life story? And I think that helped me to understand how this applies to an individual's life. And maybe you can talk a little bit about that and maybe some of the surprising things you saw in your own polygenic scores.
Yeah, I'm kind of a personal person. I wouldn't normally talk so personally, but this book was a personal book in a way. You know, when I started out in the 70s, I kept my head down. I just did the research, you know, and I didn't engage in controversy any more than was necessary. But now, after 50 years, it's kind of, fuck it, I'm going to just say it like I see it. And I think what's cool about these polygenic scores is you can think of a profile of genetic strengths and weaknesses. Now, I got to emphasize that if, say, with educational achievement, you know, tested educational achievement explaining 15% of the variance, well, that means we're not explaining 85% of the variance. It's equivalent to a correlation of 0.4. And a psychologist, you know, if you did a scatter plot between, say, your polygenic score and your tested achievement, it would be that oval shape. So if it was a perfect correlation, it'd be a straight line. We never have that in psychology. In fact, a correlation of 0.4 in psychology is considered a strong correlation. It explains 15% of the variance. Often in psychology, these findings we think are big findings are explaining 2, 3, 4% of the variance. So 15% of the variance is a lot, but more than that, I would say make comparisons like, you know, we think school quality is so important. Schools must make a difference, right? You know, how much variance does it explain? Let's test it. It explains 1% of the variance. And here we're explaining with DNA alone, 15% of the variance. So I was interested in just saying, okay, this is the world's first polygenic score profile. And, you know, my highest score was for educational attainment. Now, you should know, though, because it only explains 15% of the variance. You take people with high polygenic scores as high as mine for educational attainment, and there'll be a distribution around that. There'll be some people who actually didn't do very well at school. That's because it's a correlation of 0.4, it's not a correlation of 1. So some people say, oh, well, we just can't predict individuals that way. But I would say, look at what we do make big decisions in life on, and you'd be lucky if you're explaining 5% of the variance, not let alone 15. A lot of things, like driving under the influence of alcohol. It's reasonable to ask, how much variance does that explain? There are some people who I don't think should be driving dead sober. I mean, they're just bad drivers. And there are people who can drive with fairly high alcohol levels and do pretty well. We actually brought people in the lab, brought them up to the legal drunk limit, gave them all sorts of tests, and the range of individual difference. There's a mean difference. On average, people who are drunk out of their minds won't do as well on these hand-eye coordination and judgment tests. But what about the individual differences? They're always enormous.
Wow.
And so I'm not saying people should be allowed to drive drunk, but I'm saying we don't even know how much of the variance it really explains out there in the real world. And yet I'd be very surprised if it explains 10% of the variance myself. But does that mean I think people should be allowed to drive drunk? Absolutely not. But you just go in it with your eyes open and you say, okay, it doesn't explain much, but the deal is, I give you a driver's license if you agree to follow my rules. And one of those rules is don't drive drunk. Even if it doesn't explain much variance, it explains some variance. So we agree, you do not drive drunk. If you do drive drunk, you'll be liable and you'll go to jail. Fair enough, but not because we, it's bad to give people phony information. I mean, because then if you give a kid the feeling like, well, we've shown that if you drive drunk, you're going to have an accident. Well, it's not true. The vast majority of the time, you won't have an accident. So people say, well, that's not right. So, I can just drive drunk, I'm okay. So it's better to be honest about these things. But more than that, there's a deeper scientific fact here, that the range of individual differences is enormous for a lot of these things. And we don't often take that into account. So anyway, I don't know, how did I get off on that, Andrew?
Oh, well, we were talking about your own polygenic scores.
Oh,
and
right, yeah.
and yeah, I mean, I think really the point that I wanted to get at was eventually I wanted to talk about like treatment and prevention. So I think sometimes, people will hear us talking about the influence of genes and how they explain more variance than really anything else. And they might think, well, then I'm doomed to being depressed or, to being chronically anxious or these kinds of things, that I can't change it because it's written in my DNA. But you argue strongly against that. And so I guess I want to talk a little bit about what is if we can predict from birth, we can scan someone's or sequence someone's genome and look at their polygenic scores and say, well, this person is very likely to develop depression later in life or whatever it is. What's the opportunity there for early treatment or for customized treatment?
Yeah, I'm so glad you brought this up because this is really the critical point. By showing a genetic risk, it's still probabilistic. It's not at all deterministic. So the polygenic score for alcoholism isn't great. It's probably as good as knowing whether you have relatives who are alcoholic. So it means compared to other people, you're more at risk for becoming alcoholic. So if you have a kid and parents are beginning to get these polygenic scores for their kids, it's actually kind of a scandalous story of these direct-to-consumer companies marketing this sort of DNA testing for parents, playing off on their anxiety and saying, you've got to know what's going to happen with your kid. But just take alcoholism. If you knew your kid had a high polygenic score for risk for alcoholism, and as I say, it doesn't explain nearly as much variance as what we've been talking about, but still they have an elevated risk. It seems to me you don't become alcoholic if you don't drink a lot of alcohol. And you could just tell your kid, you're not going to become alcoholic probably, but you're more at risk for it. And universities or even high schools are sort of like testing facilities for whether or not you have a risk for alcoholism, because anybody can become alcoholic probably with enough alcohol, but some people can become alcoholic with a normal amount of alcohol. So you could say you could go out getting bombed with your friends, and maybe they won't be at risk, but maybe you will be. And so why take a risk? Why not just do what we're all supposed to do? Monitor your alcohol use, take a break every now and then, and see how much you feel like there's a craving for it. So it's a low-tech sort of solution, and I don't see the harm that can come from it, as long as you realize it's not deterministic or fatalistic. It's just information. So medicine is this is all going to happen in medicine. It'll come back to psychology through the back door. All of medicine is moving away from a model where you wait until someone has a heart attack and then you try to fix it. Because, we can fix the heart attacks. It's very expensive, but the quality of life is diminished after that. What if instead you could predict who's going to get a heart attack and then work to prevent it? And that's the way medicine has to go. And DNA is the best early warning system we have, because we haven't said this yet, but you start life with a set of DNA, a single cell with a set of DNA, half from your mother, half from your father. And that DNA is the same DNA in all of the trillions of cells in your body. So we can get DNA from any cell in your body, typically saliva, but also blood, anything, skin. And it doesn't change throughout life other than picking up random mutations. But the genetic influence that we measure with heritability, that's due to these inherited DNA differences that come from that original cell with which you started life. So it can predict from very early in life, unlike many of our other predictors. And so it's not going to be like, I don't know, your listeners are probably too young to know the 1996 film Gattaca, but it's a genetic dystopia, in which kids' lives are sealed at birth by their DNA. So they do DNA testing at birth. So I think that movie was great, actually, in terms of predicting, long before we had the genome sequence or SNP chips or anything, predicting most of the applications of the DNA revolution, like in identification. Forensics has been revolutionized by the DNA revolution. It really has been completely transformed. And then testing at birth, it's being done nationally in places in Finland, Estonia, and UK now has a big pilot project to do this, because if you can predict, even say heart attacks, say you only predict, you can predict that some kids have a 10-fold greater risk of having a heart attack. If you can predict that, there are ways you can prevent it. Usually it involves body scans. They're expensive things that you wouldn't do in the whole population. But if you can prevent one heart attack, it's said in the National Health Service here in the UK, that's about 700,000 pounds. It's getting on $1 million all in,
Wow.
for a severe heart attack, with all the rehab, and that's not even mentioning the quality of life lost as a result of this. So preventing one heart attack can make a hell of a difference. And in the meantime, all you're doing is getting people to pay attention to the messages we're all supposed to listen to about eating well and exercising. So you're not hurting anybody. It's just a no-brainer to me that you want to move towards prediction and prevention, and that DNA is one important way to do that as a supplement. It's not going to be the only thing that predicts. We're not going to use it as a sole instrument to predict. But man, it's important information. So when I talk to public groups, the counter I get is, well, what about Alzheimer's? If you do one of these direct-to-consumer company things, like 23andMe, I'm sure many of your listeners have done that. It's about $150, and they do the SNP chip, and then they give you scores on often single gene things. They got burned by the FDA, and they don't do polygenic scores, but they allow you to download your genotypes. What is it, about 2 GB is all it takes to, it's not huge, just a little memory stick will do it. And there's several other companies that allow you to upload it, and they give you polygenic scores.
Wow.
Lots of traits. And so 27 million people have done this, paid for this testing in the world. So I'm sure many of your listeners have done that. And it's going to be the case that I hope it's done nationally. It's done better, but people are voting with their feet, and they're saying, well, it's my DNA, I want to get this information. But one of the things you get from 23andMe is about Alzheimer's risk. And although most of the effects are very small, there's one gene called Apolipoprotein E. And if you have two forms of the rare allele, and only 1% of the population do, but if you do, instead of a, say, 10, 15% risk in in your 80s, you'll have over a 60% risk for Alzheimer's.
Wow.
And as medical risk goes, that's astronomical. So but there's no cure. There's nothing you can do about it. So people tell me, well, I ask public audience, do you want to know? Because 23andMe, this direct-to-consumer company who gives you that information, has a triple lock on it required by FDA. So you have to say, yes, I want to know. And then you have to come back again and say, yes, I want to know. And then you say, yes, I've read this material. Yes, I want to know. So eventually you get it. And, do you want to know? Now, only 1% of the population will get this bad news thing, but, it's 1 out of 100 people. And I find the audience splits right down the middle.
Yeah.
A lot of people say, hell no, why would I want to know? It's going to ruin my life. The other half, like me, says, well, it's information. Forewarned is forearmed. And even though there's no cure now, there are things you can do about it.
Right.
You could say, well, I'm going to, even if it's only a 60% chance, that's a big risk as medical risks go. I would organize my life differently. I would make sure I'm going to be taken care of economically and socially. And then also I might do a bit more carpe diem, saying,
Yeah.
enjoy life now while I can. So even in that extreme case, I think there is grounds, for, well, I don't know, individual differences, but I really understand why some people say, yes, I would want to know. Forewarned is forearmed, that sort of argument. And so the other part of it, though, is the science of it. The problem with all these things like schizophrenia, alcoholism, you don't learn much by studying schizophrenics or alcoholics. You want to study how people develop these disorders. Because if you're going to intervene, you're not going to get an intervention that takes people whose brains, you don't even need a microscope with an alcoholic's post-mortem. You just look at it and there's big holes in it, it looks really shot. Well, you're not going to cure that. But if you can do things early on in the process, that's, I think, where you're more likely to make a difference. So that's prediction and prevention, once again. And if you don't know who's going to become, say, get Alzheimer's later in life, it's really tough to do this. But with the DNA now, we can predict, we can get a group where they're much more at risk than your normal group for becoming, for developing Alzheimer's later in life. And so then you can study the precursors, the things that develop. And that's, I think, where we're going to make the difference in terms of intervention.
Yeah. Yeah. And I see we're nearing our time here, but I wanted to, I had this kind of hypothetical, crazy idea that I wanted to get your opinion on. So we're talking about treatment or early treatment and prevention and using this genetic information. So I wonder with depression, for example, if you think about like the serotonin system, because we know the serotonin system in the brain has something to do with depression, and seems that this is a hugely varied system. The serotonin has 15 different receptor subtypes, and they're coded for by different genes. And many of them are, I'm sure you know a lot of this, but that many of them are selectively and individually targeted by various antidepressants. So, the 1A receptor might be targeted more than the 2A receptor in certain, with certain different kinds of medications. And one of the difficulties for people who are getting prescription treatment for depression or anxiety is finding the right drug. And, I think it stands to reason that is because of these differences in the receptors, that maybe one person's, like I said, one person's 1A receptor is malfunctioning or something like that, but not their 2A receptor. And maybe it's a different case for somebody else. And it seems that, once somebody finds that medication that works for them, it seems to work for a long time. So I wonder if one of the applications of this kind of genomics research would be to, sort of pinpoint, well, this medication is likely to work for this person if they start to develop these symptoms, and kind of avoid a lot of this trial and error process that psychiatrists and their patients go through.
Yeah, no, absolutely right. I mean, that's a key area of research. It's generally called pharmacogenomics, individual differences, genetically driven individual differences in response to drugs. So most of your big treatment trials, regardless of whether it's a drug or CBT or whatever, people are collecting DNA exactly for the reason you're talking about, is to see if you can predict genetically who responds to a particular treatment or a drug. Like with methylphenidate and hyperactivity, ADHD, attention deficit hyperactivity disorder, to make it sound like a real disorder. Well, better though, it used to be hyperkinesis. So,
Right, add the Latin in there.
yeah. But if you could find, you don't like administering stimulants, amphetamines, basically, to kids, right? But it does work. As we know, I don't know about your generation, but in the 60s and 70s, we knew that you take speed and it doesn't just make you hyperactive, it gives you tunnel vision and focus. And it's the attentional components that cause more of the problems with ADHD than the hyperactivity. So it does work, to drug kids, and it doesn't just make them zombies, so you can see why parents who have a kid who's having trouble at school, like me, if they had the diagnosis ADHD, that would have been me in elementary school. Fortunately, it didn't exist then. I mean, I just couldn't stand being stuck in a seat, all day. We had these seats, they were like a railroad train, they're all locked together, the seats, and you sit in your seat and you don't get up, you don't move around, it was torture for me. So where was I going with this? So with Ritalin,
Yes.
that if you could find that you could predict which kids would respond to Ritalin, but even maybe more importantly, which kids will respond badly, because it's not just whether it works or doesn't work, it's also, whether it has bad effects. And so if you could predict that with a polygenic score, that would be the end of the game. I mean, everybody would demand to have these polygenic scores. And that's what's going to happen. It's starting to happen already with some disorders. So as I say, watch medicine to see where this is going. But know that once you do this genotyping, you can get polygenic scores for anything. It's not limited to the target trait. You can get it. We routinely get about 300 or so polygenic scores when we genotype people in our studies. Because I think that's what will make it take off. Exactly what you're saying is we can predict which treatment works best or which drugs work best and which drugs are dangerous for certain people, which I think is equally important. So pharmacogenomics is a great area, or more generally, it's called treatment by, they sometimes say, disorder interactions. But it's exactly what you're talking about, though, finding genetic differences in responses to treatments.
It's just fascinating. It's amazing. It's just blows my mind every time I think about where this is going in the future. And yeah, that's one of the craziest, coolest things that people.
I'm glad you feel that way, Andrew, but I know we're wrapping up here. But what I wonder about is why so many psychology departments still don't teach genetics. It is the hottest thing happening in psychology. And yet, there aren't many psychology departments that teach it. There probably aren't a lot of behavioral geneticists, but that's why I don't like to proselytize, but I do want to get the message out there, because I think psychology departments doing their students a disservice if they're not telling them about genetics.
Yeah, no, I think you're right. I mean, I think your book or something like it should be assigned in a psychology course. I mean, it's just so different from what you usually hear from psychologists and in a typical college classroom. I mean, it is pretty revolutionary information, and maybe it's just that, like you said, the field has only been around for what, 50 something years, and maybe it's just a slow start, but it's clearly going to become more and more important. And I mean,
Yeah.
I'm hopeful. I think, maybe I'm more optimistic than you are, but that I think it'll make its way into the
And
classroom.
I think the DNA revolution is really going to make the difference, because you don't need twins or adoptees, special samples. You can use these polygenic scores for any sample. And I should say, although it takes huge samples to find these associations and create polygenic scores, once you have that information, you can create a polygenic score for your individuals in your sample. And if it explains say 10% of the variance of polygenic score, you only need a sample of 60 to have 80% power to detect that effect. So
Wow.
I want to make sure people understand, you don't need huge samples to use polygenic scores. You need huge samples to get the data in genome-wide association studies to be able to create the polygenic scores. So I really think, I often end my talks at psychology departments by saying that clinical psychologists use the acronym DNA to refer to did not attend when clients don't show up. And I'm hoping in the future that we'll know it means deoxyribonucleic acid, and that there is a revolution afoot, and psychologists, you don't have to become a geneticist. You can just use this information to do what you were going to do, but to add a genetic component to it. And it's guaranteed to be interesting.
It is.
So join the DNA revolution.
Absolutely. And the first way you can do that is to start reading this book. Yeah. Thank you so much for talking,
Well, my pleasure.
Robert. It's
great talking to you, Andrew.
Yeah, it's been a real pleasure.
Keep up the
I
good
hope.
work.
Thank you. You as well. I would love to talk to you again to, maybe if you do write that parenting book or not, next time, anytime something happens, I'd love to talk to you again.
Well, great. Thank you, Andrew.
Hey, thank you so much for watching or listening to this episode of the Thinking Tools podcast from Sense of Mind. I hope you found it useful and have something you can walk away with. Remember to like and subscribe to this channel and the podcast. By the way, let me know what you think of this long-form interview format. I thought this would be a good way to change things up while still giving you useful information about the biological basis of mind and behavior. And just so you know, as Robert mentions in that bio, his work, his view of behavioral genetics can be a bit controversial, and there are behavioral geneticists who might disagree with some of his conclusions. So I encourage you to check out the work of behavioral geneticist Catherine Page Harden, who wrote the book, The Genetic Lottery. She has a slightly different view of things, and I think it's important to compare and contrast the different views in the field. As always, this channel is brought to you by the Diamond Mind Foundation. This video was written and produced by me, Andrew Cooper Sansone. So thank you so much for watching. I'll catch you next time.